So our topic is spreading coefficient. Imagine a rectangular column of liquid and substrate. It is made up of liquid and substrate whose cross sectional area, if you cut like this, cross sectional area is 1 meter square. Why I am taking 1 meter square? I want to make this 1 so that I will relate only energy and surface tension. That is the reason why I am taking the cross sectional area as 1 meter square. So when you break it, initially there is a interfacial tension between liquid and substrate. You break it. If you break it, you will create the surface tension of liquid and also you create the surface tension of substrate. So energy is equal to work done. Anything. Energy is equal to work done. Because you are doing work on two separate things. You are separating two separate things. Hence we named it as work of adhesion. What do you mean by adhesion? It is the forces acting between two different things. We call it as a adhesion. Cohesion, attraction between same things. It's called cohesion. So attraction between different things is called adhesion. Attraction between same thing is called cohesion. Work of adhesion. What is work of work? What work you are doing here? Okay, you need to tell the work in terms of energy, in terms of surface tension. Work of adhesion is equal to work of energy for adhesive forces is equal to, you have created two new surfaces. So created two new surfaces, surface tension of liquid plus you have created surface tension of substrate. In other class I told this one first. No. After doing the work you are creating the two new surfaces and you are breaking the interfacial tension. So minus interfacial tension. So you are creating the two new surfaces. Remember, see, don't behat this. Okay, what work I am doing? I am breaking it and I am creating two surfaces. Each surface has its own surface tension. Sir, just now you said that work is equal to energy is equal to surface tension into area. Where is the area here? Into 1. That's all. This is work of adhesion. Next, work of cohesion. Now again an imaginary rectangular tube made up of single liquid. Break it, come. Break it. Okay. When you break it, you are going to create two new surfaces. So what is work of cohesion? This plus this. Or I will write directly here. We created one surface plus we created another surface which is equal to creation of two new surfaces. Spreading. Spreading coefficient denoted by S. So spreading coefficient is equal to, when it will spread, adhesive forces should be more or cohesive forces should be more for your ointment to force. Okay, if ointment cohesive force is more, ointment never spread. Their own molecule will hold their own molecule. Now ointment molecule and skin molecule should attract each other, then only it will spread. So work of adhesion should be more than work of cohesion. Then only spreading will happen. So what is work of adhesion? This is work of adhesion minus, what is work of cohesion? This two. Why I am writing minus here? If you take this bracket and keep here, this minus, if you multiply it will become minus. Minus A plus B is equal to minus A minus B. That's what I am writing there. Cancel the common terms. Minus of liquid, plus and plus. Okay, so remaining is surface tension of substrate, okay, minus surface tension of interfacial tension minus surface tension. These two can be written like this. Do you agree? No, minus it. You will get the same thing. So this is the equation for spreading coefficient. Okay, sir, we created equation. Now you tell me what is the use of this. Okay, what it is saying is, if this one is more than this one, if this value is more than this value, overall value will be positive or negative? Positive. Hence there is spreading. So it indicates spreading. If this value is less than this value, what happens? Overall value will become negative, because negative will be more, the value will become negative. Hence, no spreading. Okay, sir, you have told this. We didn't understand. Now my ointment is not spreading. What should I do? You told this value is more, this spreading. You told this value is less spreading. I didn't understood. What should I do? What you should do is incorporate polar groups in your ointment. Why? If you incorporate polar groups will attract your skin. Okay, in any way, maybe van der Waals force, by hydrogen bonding, any bond they will form with the skin. Increase polar groups like carboxylic group. Okay, increase polar groups in your ointment, or include an excipient which has more polar groups. That's what it says. Okay, include an excipient which has more polar groups. 1. 2. This increasing, see, what should I do is, either I should increase work of adhesion, or I should decrease work of cohesion. Two things I can do. I can increase the adhesive forces, or I can decrease the cohesive forces. Increasing the adhesive forces is incorporate polar groups. Due to this, adhesive forces increases. Now come to ointment. Ointment molecules are pulling each other. They have good cohesive force. I want to decrease cohesive force. Incorporate surface active agents. If you incorporate surface active agents, the cohesive force will decrease. GPAT question. If you incorporate polar groups, adhesive forces will be increased. That's all. So you need to make this change in your formulation. If your formulation is not spreading, you prepared an ointment is not spreading properly. In that case, increase polar groups in the ointment, then also it is not spreading, no problem. Increase surface active agents in your ointment. That's how you can increase the spreading of an ointment through formulations. Because Sutix people, we are formulation scientists. So we should know what is happening there, what is problem in my formula, how to solve this problem in the formula. That what is your spreading coefficient. To study spreading coefficient only, we are studying surface energetics. Okay, main reason for studying the surface energetics is to study the spreading coefficient.